Hello and welcome to this video tutorial on count the substring. In this tutorial, we will be using the merge sort algorithm to solve this problem. We will solve this problem by mapping each one in the string to a value of 1 and each 0 to a value of -1. We can then calculate the prefix sum of the resulting array and count the number of inversions in this prefix sum array. Now, the problem has been transformed into a problem of counting the number of pairs of indices, I, j, in the prefix sum array such that the value of prefix I is less than the value of prefix j, and I is less than j, which is similar to counting inversions in an array from the rear side. Then return the number of inversions of the prefix sum array as the final answer. First, let's take a look at the main function, count substring. In this function, we first initialize a variable n to store the size of the input string s. We then create two vectors, temp and presum, both of size n. The temp vector is used to store the values of the characters in the input string s. If the character is a 1, we assign a value of 1 to the corresponding index in temp, otherwise, we assign a value of -1. The presum vector is used to store the prefix sum of the temp vector. This is done by initializing the first element of presum as the first element of temp, and then iterating through the rest of the elements of temp, adding each element to the previous one and storing the result in the corresponding index of presum. Next, we initialize a variable count to 0. We then iterate through the presum vector, and for each element, we check if it is greater than 0. If it is, we increment the count variable. After this, we reverse the presum vector and call the countinversions function, passing in presum and a variable to store the number of inversions. This function uses the merge sort algorithm to sort the presum vector and count the number of inversions. Finally, we return the sum of the inversions and count, which is the number of substrings in the input string s. Now, let's take a closer look at the countinversions function. It counts the number of inversions in a given vector of long integers. It initializes a variable inversions to store the number of inversions. It then calls the function merge sort, which takes in the vector, the start index, end index, and the inversions variable. The merge sort function will sort the vector and count the number of inversions in the process. Finally, the countinversions function returns the total number of inversions that were counted by the merge sort function. Now, let's see the merge sort function. The function takes in a vector of long integers, the start and end indices of the current subarray, start and end, and a variable to store the number of inversions. The function begins by checking if the start index is less than the end index. If it is, this means the current subarray has more than one element, and the function can continue. It calculates the midpoint of the current subarray by adding the start and end indices and dividing by 2. It then calls the function recursively on both the left and right halves of the subarray by passing in the appropriate start and end indices. Once the recursive calls return, the merge function is called to merge the two sorted subarrays and count the number of inversions. The merge function compares the elements of the two subarrays and places them in a temporary array in sorted order. If an element from the right subarray is smaller than an element from the left subarray, this means that there is an inversion, and the inversions count is incremented. Now, let's see the implementation of the merge function. The function takes in the input vector of long integers, the start and end indices of the current subarray, start and end, the midpoint of the current subarray, mid, and a variable to store the number of inversions. The function begins by creating a temporary vector temp with the same size as the current subarray. It initializes 3 pointers I, j, and k, where I is set to the start index of the current subarray, j is set to the midpoint plus 1, and k is set to 0. The function then enters a while loop that runs while I is less than or equal to the midpoint and j is less than or equal to the end index. Inside the while loop, it compares the elements of the left and right subarrays at the current I and j indices. If the element in the left subarray is smaller or equal to the element in the right subarray, the element from the left subarray is added to the temp array, and I is incremented. Otherwise, if the element in the right subarray is smaller, the number of inversions is incremented by the number of elements remaining in the left subarray, mid-I plus 1, and the element from the right subarray is added to the temp array. After the while loop, if there are any remaining elements in the left subarray, they are added to the temp array. Then, the same is done for the remaining elements in the right subarray. Finally, the function copies the elements in the temp array back to the input vector, starting at the start index and going to the end index. This merge step of the merge sort algorithm is responsible for combining the two sorted subarrays and counting the number of inversions. It does this by comparing the elements of the two subarrays and placing them in a temporary array in sorted order. If an element from the right subarray is smaller than an element from the left subarray, this means that there is an inversion, and the inversions count is incremented. And that's it. We have successfully implemented the merge sort algorithm to count the number of substrings. I hope this video was helpful and have a better understanding of how this problem can be solved using the merge sort algorithm. Thanks for watching.